Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to take another nice or light session in probability and statistics. If you remember last time, I posed like a riddle and I told you to think about it. And it was about a biased coin. So biased meaning it's either gives you more heads than tails or more tails than heads. It's not 50-50, but you don't know how what probability these two probabilities are. And we want to use that coin, which we don't know its probabilities, to make a fair game between two players. Okay? I didn't receive anything, and I told you don't use statistics because when I asked this question to college students when I was teaching probability and statistics, the main response I got was always, toss the coin 1,000 times. I told them I don't have time to do that, so do it for me, please. And record how many tails and how many heads, and you get roughly the idea of the percentage. I said, but that's not what I want. I don't want to use statistics, and I don't have time to toss it 10,000 times or million times. Okay, so anyway, here is the solution. The solution is so easy. We are going to devise a game between you and me, okay? Let's say you pick the head and I pick the tail. So the game works like that. If we get two heads or two tails, because we are going to toss the coin twice, not once. Toss the coin twice. If we get two heads or two tails, we discard the game and repeat. If you get a head then a tail, you will be considered winner. If we get tail then a head, I will be a winner. So let's think how that works. Let's suppose we said we don't know the probability, but let's pick any number. Let's say it was like head is 0.7 and tail is 0.3. So if I toss it twice and get two heads, the probability of that is 0.7 times 0.7 or 0.49. And if I get two tails, and that would be, so this is two heads, two tails would be 0.3 times 0.3, which is 0.09. 9% of the time I will get two tails. 49%, roughly half the times I will get two heads. But if I get a head followed by a tail, that would be a probability of 0.7 times 0.3, which is 0.21. And if I get a tail followed by a head, the probability of that is 0.3 times 0.7, which is also 0.21. So I made a fair game. Yeah, that was like a riddle or just a we were playing. Okay, and of course, if you add these, you get 42, and plus 9 is 51, plus 49 is the 100%. Okay, so that was that riddle. Today, I'm going to give you two more, but I will give you the answers during the video. So once I give you a problem, you can pause and think about it and try to solve it. So I'm not going to wait until you comment to me. You can tell me that I did it if you want. I would feel good about it, but you don't have to respond. Okay. So what is the first one? The first one is, suppose we know that I'm a great crazy soccer fan, okay? And the soccer World Championship will be held in the US, Canada, and Mexico this year. So two of my friends and myself, we decided to get tickets to attend the final. When we went online to see the price of the tickets, oh my God, it cost an arm and a leg. So I said, no, we can't do that. So let's devise a game. We are going to get only one ticket and three identical boxes. We're going to ask one of our friends to go outside the room, place the ticket in one of the boxes, shuffle them, and put them in front of us. The question is, so I have three boxes, box 1, box 2, and box 3. Only one of them has the ticket, the other two are empty. So we said, okay, we are going to make a game. So one of us, we can play like a game to decide who's going to go first, okay? And whoever goes first will pick a box, will open it. If it has the ticket, he or she wins. If not, that we will discard it and leave the other two. Then the second player would pick one of the two. If it has the ticket, he or she wins. Otherwise, the third and the last one, of course, once we discard the second box, the third one is guaranteed to win because there's only one box and definitely the ticket is inside. The question is that a fair game? So don't say yes or no by guessing, oh, it looks like it's no, or it looks like it's yes. No, try mathematically to show whether it's a fair game or an unfair game. That's the first riddle. You can pause the video now and go work on it and come up with your answer. Okay, if you want to do it, pause it now. Okay, now I'm going to give you the second riddle. So after you come back, you will see that. The second riddle said something similar. We have two players. We are going to, we can say toss a coin, or let's say we are going to roll a die. Okay? And we want to see whoever gets 6 first wins. So maybe you are going to toss a coin to see who's going to play first. We are two players. So let's say you won. So you're going to roll the die. If you get a 6, the game is over, you won. If not, it's my turn. So I'm going to roll the die and see if I get a 6 win. And we keep doing that until somebody gets a 6. Is that a fair game? You show me whether it is or it's not. And if it's not, you have to tell me who has the higher chance and what are the probabilities of each player winning. You can show it's 50-50, in which case it's a fair game, or you can show that one of the players has higher probability. Again, if you want to solve that, pause the video, go solve it and come back. Now, since you came back or you didn't go away, it means we can go over the answers. The answer to the first one, it is a fair game. What? Isn't the first one has a higher chance? Let's see. Here is player number 1, here is player number 2, and here is player number 3. Player number 1 has 3 choices, right? Box 1, 2, or 3. So the probability that 1 wins is 1/3, right? So there is a 1/3 chance he wins and 2/3 he loses. What is the probability? Let's say player 1 picked box 1. If it has the ticket, he wins. If not, then we only have boxes 2 and 3. It's a 50-50, right? But notice, he doesn't have 100% chance. There is only 2/3 probability that the first didn't win, in which case you get a chance to play. So the probability that number 2 wins is the 2/3, meaning the first has to lose and the second has to win, and the probability of winning is half, right? There are 2 boxes. He picks the correct or the wrong. So times 1/2 equals 1/3. So the probability that 2 wins is also 1/3. Now you can say that since 1/3 plus 1/3 is 2/3, then the probability that the third wins is 1/3. Or you can say, okay, let's say number 2 picked 2 and it was empty. So number 3 has only 1 box, which is 3, but there is a 1/3 chance that number 1 has already won and 1/3 chance number 2 already won, meaning there is only 1/3 chance that it would reach number 3. But if it reaches him, the probability of winning is 100%, which is 1. So you get 1/3, 1/3, 1/3. It is a fair game. Maybe intuitively you think, oh, if I go first, I have a higher chance. No, you don't. Unless you have an accomplice, the other guy who went outside to place the ticket is your friend, and somehow with you had like your earpiece and he told you it's your number two. I'm just kidding. No, so it's a fair game. How about the second one? Let's see. The probability that player number one wins is what? Either he tosses the coin, he rolls the die and he gets a 6, and the probability that is 1/6, right? But what if it's not? Then it's a probability 5/6 that he lost. But then in order to win, the second player also has to lose. That's another 5/6. So it goes back to the first. The probability that he wins the second time is 1/6. Or the first one loses, and the second one loses, and the first one loses again, and the second one loses again, and the first one wins. Do you see that? So it's 1/6 plus 25 over, or let's write it 5. No, let's write it 25 over 36 times 1/6 plus, this is 25 over 36, and that's 25 over 36, so 25 over 36, quantity squared times a 6, plus, and you can see the next one would be 6 times. Lose, wins. So 5 over 6, 6 times, or 25, 36, 3 times. So 25 over 36 cubed times 1/6 plus till infinity. You say, okay, so how do I calculate that? Go back to to algebra and see how when you took how do you calculate the geometric series? We'll see. First of all, if I pick 1/6 out as a factor, I will get 1 plus 25 over 36 plus 25 over 36 square plus till infinity. We learned that if we have a geometric series and the multiplier is less than 1 and it's infinite series, it sums up to what? So if I tell you, for example, what is 1 plus 1/2 plus 1/4 plus 1/8 plus till infinity? The answer is 2, by the way. But how do you do it? You say the answer is 1 over 1 minus the multiplier r. And you multiply here by 1/2. So 1 over 1 minus 1/2, it's 1 over 1/2, it's 2. So same thing, the 1/6 is a constant. The sum of this series is 1 over 1 minus 25 over 36 equals 1/6 times 1 over 36 minus 25 over 36 equals 1/6 times 1 over 11 over 36 equals 1/6 times 36 over 11, divide by 6. You get the answer is 6 over 11 for player 1 and 5 over 11 for player 2. You don't need to do the player 2 since we already know that they have to add up to 1. But if you want, you can say, okay, the second player, and you can see it's almost identical. The logic is the same. In order for number 2 to win, either the first lost, then the second one, or the first lost and the second lost and the first lost again, then the second one, plus. So now if I take 5 over 36 as a common factor, that would leave me with 1 plus. I took these out, so I get 25 over 36. Then I get 25 over 36 squared. You see that? Do you see that? I know the sum of this is 6 over 11, so I get 5 over 36 times 6 over 11. Simplify the 6 with the 36. What did I say? Oh, I'm sorry. This is 5 over 36, and that's before multiplying by the 1/6. It's 36 over 11. Do you see that? I'm sorry. I took the final answer. Notice I multiplied 1/6 by what's inside. So what's inside was 36 over 11. So the 36 would cancel with the 36, and you get 5 over 11, as we said. And as I said, it's a short video. It's just I want to show you some nice stuff you can do. You learn about in infinite geometric series. If r is less than 1, or the absolute value of r, r is less than 1. And then we also learned one that is quite counterintuitive, that the 3 players, it doesn't matter who starts, they have the same exact chance of winning, unless you know the guy outside. Just kidding. Thank you for your time, and I hope to see you soon. Bye.